That is 2x plus 4 if x is greater than 1, and that is x plus 2 if x is less than or equal to 1. And you do not have to graph this one. You just have to find g of -3, g of 1, and g of +3. What does that mean?
Plug this in.
Yeah, you gotta plug it in. Plug it in, like the commercial says. But sometimes the plugging in is not as easy for you as it looks. So if you're looking for g of -3, which of the two functions do you have to plug it in? You can't plug it into both of them because they both have a restriction. Transitional point is 1. So if you're being asked to find g of -3, do you plug it in the first one or the second one? See, there I hear two different stories. I hear second one, I hear first one over here. See, this is your x value, right? In this case, x is -3. Into which domain falls -3? That would be the second one. So you can only use the second part of this function, -3 plus 2, which is a -1. X is less than or equal to 1. You have to use the second piece. Does that make sense to everybody? X is -3, which falls into this domain. G of 1, which one you're using, first or second? That would be correct because it says x is less than or equal to 1. So that would be 1 plus 2, which is 3. And now you have to find g of 3. Where does g of 3 fall into? The first one, x is greater than 1, and 3 is greater than 1. So 2 times x, which is 3, plus 4 is 10. Yep. Yes. Okay. So you have to pay attention to your x values that are right in here, and where do they belong? Do they belong to the first equation or function, or do they belong to the second one? Yes, guys? Yeah. Okay. I think that's all I want to do. No, I don't want to do this. Talked about that. Let's talk about 2.7, transformations. I just did that in the beginning in 5 minutes of this class, so who can remember what I said? Okay. The first transformation, the book also calls it translations. I call them transformations. Is a vertical shift. A vertical shift that is going up and down. Up and down. Just like my blood pressure. Well, I read here 2.7. Blood pressure is the force of blood per unit area against the walls of the arteries. Blood pressure is recorded in 2. No, okay. Why are we talking about blood pressure? Because there is some mathematical I haven't had French in so long. Poiseuille's law for artery blood flow. There we have it. Okay. So, transformations, vertical and horizontal shifts. We're going to look at the vertical shift first. A vertical shift means you're going up or down. Let's just talk  Vertical shift means your graph is going up or down. So if you add some kind of number on the outside, this is what that means in general. If you add some kind of number d to the outside of your function, you're going up. If you subtract, you're going down. Let me give you an example. Which graph you want to use of the parent functions? Tell me. Give me a parent function. A square. Okay, the parabola. Why not? So here's my parent. Drip, 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 drip. F of x equals x squared. Point of reference with the parent function, the x squared, it starts at 0, 0, life is good. Now, a different color. If we say in purple, I want you to do f of x equals x squared plus 2. X squared plus 2, see how this plus 2 is on the outside of my parent function? I'm just adding it. That means my point of reference 0, 0 becomes now 2, 0, or 0, 2, and it looks like so. I have some work for you to do. That's why I'm trying to see what I'm looking for. Can't remember what. There it is. Okay, now if we're subtracting, what happens? We're going down real fast. We're going downhill. Let's say f of x equals x squared minus 3, 1 to negative 3, and this parabola looks like so. You see how I'm just sketching that? Now, if I want exact y values, then I ask you to make a t-table. But if I say just sketch the graph, then what I'm really interested in is really this point here. The points where it's doing the shifting up or down. Of course, I'm also looking for that you know it looks like a U. So what happens here is the y values are changing. The x values stay the same, the y values are changing, and from x, y, I found this table, I probably posted. This becomes x comma y plus d, d is the value, or it becomes x comma y minus d. So the y values in your coordinates are changing. And that's called a vertical shift. So what I'm asking you to do, like on the test, I'm asking you to tell me what's the parent function. I'm asking you to tell me what are the transformation. And then I may have you graph it or not. It's not always that you need to graph it. Like I don't like cube function all that much, so I don't have you graph that many cube functions. What's the next shift? The next one in the book is horizontal shift. Are you ready? Yes? Mm-hmm. Okay. I was just looking at John.
I was wondering if that's x1 or if that's x comma y.
That's x comma.
Thank you.
So if you have, for example, 1, 1, and you add, you're going up to, it would be 1, 3. If you have 1, 1, and you're going down 3, it would be 1, negative 2. That would be the point. Okay. Horizontal shift. Now horizontal shift is going left or right. You're sliding across the x-axis, left or right. And this time, I call it the shift happens on the inside. Up and down's on the outside, and when you're going to the left or right, you're adding or subtracting a number on the inside. There's usually some kind of parentheses there. And if you see x minus c, that means you're going to the right. If you see x plus c, you're going to the left, opposite of what you're thinking. So somebody give me a parent function. We just did that.
X plus 3, radical.
That's not a parent function. Okay, an absolute value is a parent function. John, what you gave me was like transformations already. I just want, and we're going to write all these parent functions down. So the parent function, the absolute value of x, drip, 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 looks like a V. It's just a sketch. Absolute value of x. What time is it? Okay, we're good on time. Now, if I want you to graph f of x equals the absolute value of x plus 3, that means you're going to the left 3 units from 0, 0. You end up at -3, and that is your new tippy point, and it looks like so. Horizontal shift on page 288. Well, maybe we can do some of them in the book. If I want you to graph f of x equals the absolute value of x minus 4, in this case, 1, 2, 3, 4, you're going to the right 4, and your tippy point is at 4. Oh, look at that. Beautiful. This would be right 4, and this is left 3. Right, that affected the y. So if, for example, the parent function had 1, 1, that's one of your points. If I add 2, this becomes 1, 3.
So I was just wondering like how it would look like. Is the one we just did that was on the inside of the...
Oh, now the x values are changing.
Yeah.
So here we have x, which was 0, 0 plus 3 equals 0, and you get x equals -3. If you set it 0, that's how you get this. That's how you get the -3. So the ordered pair would be x minus c comma y. And here we have x plus c comma y. So whatever your x value is, you're either subtracting 3, so 0 minus 3 is minus, well, maybe I should. I'm always thinking of finding the 0. So if you're going to the left 3, what you have here is 0 minus 3, which is -3. You go over here, you go to the right, which is start from 0 plus 4, and that is 4. That's how you do that. I'm confused adding 0 to a number.
Can you write it out like you did with the ordered pairs? Like how you did the y values are changing?
Yeah, I did right here. See? The x values are changing. So you got x plus c when you're going to the right, and you get x minus c when you're going to the left.
If we added, like, if we had f of x equals absolute value of x plus 3 plus 2 on the outside.
Oh, yeah. Well, hold on. It's okay. Hold on. Everybody copy that?
Hold on.
Hold your thought.
Okay.
So, let's say, and I will post all of that so you can look at that again. F of x is, Elisa, tell me again what you wanted. X
Plus 3
on the inside
and then
plus 2. Okay, good problem. So you guys tell me, what is the parent function here? The PF.
X plus 3.
No, that's not a parent. Anytime when you're adding a number, it's not a parent anymore. When you're doing something with a number other than exponent, it's not a parent anymore. What is the parent here? No, the absolute value of x. That would be the parent. And then the transformations. On the inside, it says plus 3, so that means you're going to the left 3. On the outside, it says plus 2. That means you do what? You go up 2. Now, when I say sketch it, I mean sketch it. Let me sketch you this real quick. So, and you can, as a guide of reference here, you can graph your parent function. We're going to the left 3, 1, 2, 3, and we're going up 2. So our new point of reference, our new vertex is right here, and there is your graph. This would look like so. Good question.
I already have something like this.
Oh, yeah, about 20 of them.
Wait, when is our next test?
I don't know yet. Probably Tuesday in a week. I have to look at the schedule. We have to still cover operations of functions and inverse functions. That may take us until the following Tuesday. So guys, does this make sense?
Yes.
Left 3, up 2. Maybe, let's take a look at parent. Can I spell parent? No, I can't. Parent functions. Parent functions are f of x equals x squared. F of x equals the square root of x. F of x equals absolute value of x. F of x equals x to the third, and f of x equals the cube root of x. 2, 4, 5. These are our 5 parent functions that we're dealing with in this chapter. And these are, so the parent function, other than the exponents, cannot contain any numbers. Because as soon as you add a plus 3, it's a transformation. Because now you're moving it up. It's not a parent anymore. So be careful about that. Okay, a reflection. Next transformation, a reflection across the x-axis. You multiply by a -1. That's called a reflection across the x-axis. Reflection across the x-axis. Ooh, I like your color. Ooh, I like your pens. Reflection across the x-axis means instead of opening up, it's opening down. No. You multiply by the y values change to the opposite. So real quick, the most famous of them all, if we look at the square function, this is the parabola. A reflection would look like so. So this is f of x equals x squared. This is f of x equals -x squared. And our ordered pair would change from x and -y. Okay, how much time do we have? What time is it? 1:35. Let me just tell you the last two. We talked about them already. Stretching and compressing, shrinking. You stretch if you multiply by a factor that is greater than 1. You shrink if you multiply by a factor between 0 and 1. So in the book calls this factor A. So f of x would be like 3x squared. Three x squared, you get tall and skinny. And if you have f of x equals 1/3 x squared, then you shrink and you get wider. 1/3 x squared. There you go. And I will definitely do examples next Tuesday. I just wanted to show you. These are all the transformations we're going to talk about. Now I gave you two graphs that you just have to sketch. You name the parent function. We just wrote them down. And then the transformations, and then you sketch it. Basically, I'm really just looking at where did you move it to. X plus 3 squared minus 1. We did something similar, and then the square root of x minus 2. Now with the square root, the x minus 2 is on the inside. You can make a t-table if you want to, but you don't have to. You just make a sketch. And you can help each other, talk to each other.
What's the name of the parent function? Like if it's f of x equals x squared?
That would be the equation of the parent function. Well, the names of the parent functions, they are in the book on page 257. And I call the first one, I didn't call it a square function, I call it a quadratic function. That would be the proper name, either name, quadratic function or square function. Then you have the equation, then you know the transformation, so from your parent function, don't forget, do your homework. Next week we're gonna do some homework problems that I ask you. If they're done, you don't have to worry about them. Nobody's talking to each other? Okay.